So in this question here, we're going to find the interval of convergence of this power series, n equals 1 to infinity, and we're going to sum up x minus 4 to the n divided by n cubed 3 to the n. Now, with this kind of power series here, I'm going to break this apart into a few little bits first. So first of all, I'm going to find my nth coefficient. So that will be my an, I'm going to call that. So an is all the terms excluding the x. So I'm going to be left with 1 over n cubed 3 to the n. So I'm going to put that over here. That's a good place to start. That's going to tell us what kind of test we're going to use to find, first of all, our radius of convergence. So that's what we got first. Then our series with our x is x minus 4 to the n. So I'm going to write that here next to that. So here I'll have a integer here of 4. So I'm going to call that c. So c equals 4. So that will come in useful when I'm finding my interval. Okay, so now what I want to do is work out what kind of test I'm going to do to find my radius of convergence. So for the radius of convergence of this series, the best thing to find that will be the ratio test. So the ratio test. Now the ratio test, as you imagine from the name, it's got a division in it. What it finds is the limit as n approaches infinity of the absolute value of the an plus 1th coefficient divided by an. So that's the nth coefficient. So if this is the series, the test that we're going to use, I've got my an. I now need to name my an plus 1. So an plus 1, so that's my n plus 1th coefficient. So that will then be n plus 1 for these terms here. So that's 1 over n plus 1 cubed and 3 to the n plus 1. And then that will give us some indication of how this grows as n approaches infinity by finding the next one in the series. Okay, now let's find a value for this. This one here, as n approaches infinity, I'm going to use the letter k. Now that will give me a value where I can find my radius of convergence. K will not be my radius of convergence, but that will give me a tool in order to find the answer to that. So let's go straight into this one. So let's find k. So k equals the limit as n approaches infinity, absolute value, an plus 1. So then I could just write this in the denominator. So then I've got n plus 1 cubed, 3 to the n. Now instead of writing 3 to the n plus 1, this is just the same as 3 to the n times 3. So I'm going to write that like that. That's going to come useful in my algebra later. And then my numerator for my ratio test would be an, because an here, if I take the reciprocal, I can then put n cubed 3 to the n in my numerator. Okay. Now what I want to do is try and simplify this with some algebra. Now 3 to the n is in both numerator and denominator, so they can cancel. This 3 can stay as it is, but here I've got n cubed divided by n plus 1 cubed. So let's just rewrite that. So then I've got limit as n approaches infinity, absolute value n cubed divided by n plus 1 cubed. I can multiply that now by a third. And I want the absolute value of that. So that will break that down. So n plus 1 cubed in my denominator, this here will approach 1. So if I just rewrite this out, n cubed divided by n cubed plus 3n squared plus 3n plus 1. So if I expanded that out, that's what I would get. Then if I divide all the terms by n cubed, so divide all these by n cubed, so as n approaches infinity, 1 over n cubed will become 0, so that will cancel. 3n over n cubed, that will also become 0. 3n squared divided by n cubed, that will also approach 0. N cubed over n cubed, that just becomes 1. And n cubed over n cubed, that also becomes 1. So as n approaches infinity, here, this will just approach 1. So this all approaches 1. Okay, so therefore this, as n approaches infinity, will just become 1. So that become 1 there. So then my value for my k will just be 1/3. So let's take this off the board and write in my value for k. Okay, so k equals 1/3. So my radius of convergence will be 1 over k, which will give me 1 over 1/3, which equals 3. So that's my radius of convergence. Now what I want to do is try to find my interval of convergence, and that's where these bits come in. So my radius of convergence, I'm going to set that in some inequality now. So now I've got x minus 4 to the 3. So x minus 4, that's going to give me 3 there. And then my lower bound will be minus 3 by virtue of k being calculated from an absolute value. So I've got minus 3 to positive 3. So let's put a positive in there so we can clearly see that. And now what I want to do is try and solve for my x. So using inequality laws, if I add 4 to this side, I'll add 4 here, I'll get 1 and leave my x there. So I'll also need to add 4 to this side. So then that will also be 7. So my interval of convergence will be between 1 and 7. So now what I want to do is to find out what happens when x equals 1 and when x equals 7. So let's find that out next. So if I just write my interval here, and then what we'll do is we'll check the boundaries at 7 and 1 using this power series here. So let's take this off the board and let's do that. Okay, now let's find out what happens at our end points. So let's have a look when x equals 1. Let's see if we can include that in our interval of convergence. So now we're going to plug in x equals 1 into this here. So we'll have the limit as n approaches infinity of 1 minus 4 to the n divided by n cubed 3 to the n. Well, here we've got n cubed, and here we're going to have minus 3 to the n, and here we're going to have positive 3 to the n. So let's just simplify that up now. So the limit as n approaches infinity of minus 3 to the n over n cubed 3 to the n. Now I can rewrite this as the limit as n approaches infinity. Now as this is going to alternate, I'll write minus 1 to the n for my alternating series, and then 3 to the n divided by n cubed 3 to the n. So then these 3 to the n's can cancel out, and then all we're left with now is minus 1 to the n divided by n cubed. Now by the alternating test, this will now converge to 0. So as that approaches infinity, this will approach 0. So hence this here converges. So that means we could include this in our endpoint. So we can put x is greater than or equal to 1. Now we need to test what happens when we get 7. So let's take this off the board and let's plug in 7 and see what we get. Okay, let's plug in 7. So we want the limit as n approaches infinity of 7 minus 4 to the n over n cubed 3 to the n. Now clearly we can rewrite this as 3 to the n in our numerator, so let's just do that quickly. So then we've got 3 to the n divided by n cubed 3 to the n. And this is not an alternating series, but the 3 to the n's can still cancel out, leaving us with a 1 over n cubed. So the limit as n approaches infinity of 1 over n cubed, that is also 0. So therefore we can include the point where x equals 7 in our interval of convergence. So therefore our interval of convergence as 1, 7. So we put the square brackets in to include the endpoints. Okay.